Now we will take a look at expanding our concept of what it means for an equation to be able to be solved through factoring. So no new concept will be introduced here other than just using the techniques that you've already learned in algebra courses to factor an expression in order to solve the equation. So we'll have to remember our techniques of factoring. So here we have a trinomial, and you'll notice that it is in descending order. And so let's go ahead and look at any GCFs. So you'll notice that there is a common factor of x in each term. So let's go ahead and factor out our x. And now we have a trinomial that we can factor by trial and error. So 6x squared, we need to factor. And then we also need to look at factors of -5. So if you want to go ahead and try factoring this trinomial into two binomials, go ahead and pause the video and see how you do. So 6x squared can be broken up as 2x and 3x. The signs will be different, so let's try plus and minus, and we will try for 5. That's either going to be 5 and 1 or 1 and 5. So let's try 1 and 5 first. If we do that, we get 3x and -10x. That gives us 7x. We're shooting for 13x. So that's not correct. So let's go ahead and try to switch the 1 and the 5. If we do that, we get 15x and -2x. That is our positive 13x. Now, we have three quantities that are multiplying to give 0. That's only possible if at least one of them is 0. So x equals 0, or 2x plus 5 equals 0, or 3x minus 1 equals 0. This would mean x would equal -5/2, and this would be x equals 1/3. So our answer is x equals 0, -5/2, or 1/3. So now let's take a look at this equation. Here, the polynomial on the left-hand side does not have a common factor. However, there are 4 terms, and if you remember from your algebra class, when there are 4 terms, we can try to factor by grouping. It's never a guarantee that factoring by grouping will always work, but it's worth an attempt. So to factor by grouping, we group the first 2 terms, and then we also group the last 2 terms. So the last 2 terms are -9x minus 45. Now, the operation between these two binomials is plus. Most common mistake that a student will make is to just pretend that that's multiplication. But no, it is an addition. Now, out of the first grouping, we have a common factor of x squared. So that would leave us with x plus 5. Out of the second grouping, we have a -9x minus 45. -9 goes into both. So 9 goes into both, but since this leading coefficient is negative, we factor out a negative version of that GCF. So -9. And what would we be left with? X plus 5. Now, at this point, it would be worth checking to make sure that this is indeed what we started with. So is it still this polynomial on the left-hand side? So x squared times x plus 5x squared, so x cubed plus 5x squared minus 9x minus 45 equals 0. Now that we've grouped and factored out of each grouping, you'll notice that we have a common factor of x plus 5. So we're going to treat that as our GCF, and it is x plus 5. So it's coming outside. What are we left with on the inside? X squared minus 9. Now you might be going, why is this x plus 5 not squared since I had two of them? Well, let me just remind you, if we had x squared a minus 9a equals 0, if I factor it out in a, I would have an a in front. I would not have an a squared in front. This a would get distributed to each. Likewise, x plus 5, if I were to multiply this out, I would take x plus 5 times x squared, x plus 5 times negative 9. So, now we can factor further. X plus 5 and x squared minus 9 is a difference of squares. X plus 3 times x minus 3. So now we have three things being multiplied, and their product is 0. That's only possible if at least one of them is 0. So x plus 5 equals 0, x plus 3 equals 0, x minus 3 equals 0. So x equals negative 5, x equals negative 3, x equals 3. So we have three solutions that would satisfy this equation. X equals negative 5, negative 3, and 3. Now here's a more complicated version of what we're doing. Here we have an equation, and if we look at trying to factor, notice x squared plus 3x to the 1/2 is common to both. So let's use that as our GCF. So it's common to both. So I'll put it in front, x squared plus 3x, and that's raised to the 1/2 power. What's left? 2x minus 4. Don't forget the equal 0. This is still an equation. So now we have x squared plus 3x to the 1/2 and 2x minus 4 have a product of 0. That's only possible if at least one of those is 0. So x squared plus 3x to the 1/2 equals 0, or 2x minus 4 equals 0. Well, to the 1/2 power is the same thing as square root. So I can undo that 1/2 power by squaring both sides. So x squared plus 3x would equal 0. And I can factor that by taking out a factor of x. And so, again, I can apply the 0 factor principle. So x would equal 0, or x plus 3 would equal 0. So x would equal negative 3. Now if we come over here, this would mean that 2x equals 4, or x equals 2. So we have x equals 0, negative 3, or positive 2.